Welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. We are still developing an unassemblize tool, and we want to continue with the analyze named functions async function. Okay, so what do we do in there? Build bundled functions. Build matched functions. Oops, sorry. I think we can simply chain the three commands together. Or not. I see. Async load. Save config async. So maybe we just chain it like we did it here. Would that make sense? Let's see. Here is. I think we can run the disassemble and then load source files. We can run this in parallel. These don't have to be a chain. So I think we have one scope here where we put the auto commands, create disassemble. What's this? Here, selected functions commands. We give the revision descriptor, and the named function indices. And then we just enqueue this guy, right? Commands. What's the problem here? Oh, std move. On the note of std move, I think I remember there was a function where we passed a std function and we didn't use move semantics for that, which I wonder is a waste. What was it? I can't remember. It was one of these, no? Here. Filter callback. Yeah, I wonder if we should pass this as std move. I think. I hope that makes sense. Okay, so yeah, enqueue, and I think this makes sense. And then we will have another auto command equals create build source lines, and there we pass the same stuff. Hold on. Source lines, does it need the disassembly? Hold on. We should look at that. I think it may have a dependency. Runner disassemble selected functions. No. Build source lines for function is linked to source file or not can link to source file. Get begin find function by address. Set source file. This requires the instructions to be built. Okay. So this has to happen after this disassemble step, yeah. Instructions are built on disassemble, yeah. Okay, so it actually needs to be in order. Yeah. Okay, back to ImGui app. So, where are we? Down here. So instead we do command dot commands chain to last. Chain to last. Maybe we should. I actually wonder what happens. I think this was not actually thought about. What happens if we chain here a command that is also a chain? Did I ever thought about that? So has delayed commands and Q next delayed commands. Yeah, I'm actually not sure. Evaluates and enqueues next commands. Has delayed commands, enqueue next delayed commands. Yeah. Yeah, I'm curious. I wonder if we have some logical mistakes here somewhere. Looking at this. Because essentially here, let's comment this stuff here. Let's go to save config async. I'm a bit confused right now. Why does this work? Create, save. So here we create a new command. But chain. I'm second guessing here my own creation. Here, chain command, create. Loses original command chain if next delayed command is set. Okay, we move the, right. We move the next delayed command to the new command that was created here. Okay, then this is fine. Yeah, okay. I see. Loses original command chain if next, yeah, okay. Yeah, okay, makes sense. So if we created here a command, why don't we, let's go back here. Why here, the chain command, why don't we move our next delayed command to the very end of the chain? How about that? Maybe that would be better, yeah. So we say, chained command, chain to last. Well, it's not chain to last, it's chain to last wants to create a function. Get last delayed commands. We need to call this one get last delayed commands, and we give it chain commands. No? Get last delayed command. What? Dot get. And this one returns while next command has delayed commands. Yeah. So we say last delayed command. And then we say last delayed command, next delayed command, std move. This means that we can insert chains, and then the previous next chain would be at the end of the new command. Okay, so I think this would be good. Yeah. So let's call this last command. Last command. Moves next delayed command. Moves next delayed command to the very end of the new chained commands. Moves next delayed command to the very end of the new chain command. I think this makes more sense, yeah. Delayed var can decide to not create a chain command. In this case, the command chain is done. Does that make sense though? Shouldn't he then try to go to the next delayed command afterwards? That would make more sense, no? Delayed var can decide to not create a chain command. Delayed var can decide to not create a chain command. Wouldn't it make more sense if we get a null command in our chain, then we just go to the next one. We don't just drop the entire chain. I think that would have to be like a very explicit thing that we would instruct. But let's say we have a chain of 20 things, and just one of these decides to not do work, then we would return a null command, but it wouldn't break the chain. The chain just keeps on working. Yeah. Although, of course, it's questionable, like, what is the purpose of the chain if there are things inside that can just do nothing? It's kind of weird. Delayed work can decide to not create a chain command. I think what we should do here is we can do a while delayed commands creates next delayed commands is also this. Okay. How about we say while delayed commands is not null pointer. Then here we do return false. While delayed command is not null pointer. Chain command creates. Okay, if chain command is null pointer, then we do continue. Wait, we do delayed command equals std move std move delayed command next delayed command. There we go. And then continue. Otherwise, delayed work can decide to not create a chain command. In this case, the next delayed command is worked on. Okay, otherwise moves next delayed command to the very end of the new chain command. Last command, chain command gets. Last command, next command, yeah. Return and queue. Okay, this makes sense, I think. So we can have holes in the creation that can be return null, but then what it does, it doesn't break the chain. Instead, it just moves to the next thing to work on, yeah. So the chain doesn't break by default. It never breaks. We could have like a setting if we really needed that functionality, but I don't see this right now. And then if we create another chain command in between, then it gets inserted in the chain. And the would-be next delayed command is put to the very end of the new command that was created here. Yeah, I think this would work. Yeah, I do wonder, like this function is weird because here we pass a work queue delayed command and we only take the next delayed command instead of taking this one here. This is kinda, isn't that weird? Hold on, create. It is weird, yeah. But maybe not. Delayed commands. Yeah, this is a bit weird here, but I can't think of a better way right now, so I don't know, just stick with that for now, I guess. Maybe there's a more elegant way, because it's kind of weird that the head that we pass is not used to evaluate anything. But the problem is that we can't set this create function here. It's private, right? So we would have to, like, I don't know, like, I don't know. Maybe we would need to have something like a struct work queue delayed head command. I think we already experimented with this earlier. Head command, which basically is, which is that. And then I don't know, seems to be not necessary for now. Yeah, okay, but let's think this through once more. So we have a while. I need some water. Okay. So we have delayed command. While it's not null pointer, we use it to create. We give it the previous result. Which is kind of questionable how useful this really is, this work queue result pointer. And then we if it's null, then delayed work can decide to not create a chain command. In this case, the next delayed command is worker. So we move the next delayed command to here, yeah. And then continue. And then it again creates a new chain command. Yeah. Moves next delayed command to the very end of the new chain command. Yeah. Last command, next delayed command, move and queue. I think it's correct. Yeah, maybe. We will see. Good. Let's get back here to this code. So we create this assembler. Chain to last. If we chain here, what do we get? Make unique, right? we return the stuff that we have just created. Okay. With chain to last, get last chain, std move. Yeah, I think it's correct. Yeah. I was wondering if like this thing that it returns, is it actually then the last new thing? But I think it is, because we only add one. We don't add multiples, right? So I think this is correct. Oh, hold on. Commands. Okay, how about we do the same way this one here. Let's move this up here. Head commands, next commands. Next commands. Next commands equals next commands chain chain this thing return this thing. Okay, it doesn't know about the revision descriptor. Oops. Let's make copies. Okay, this doesn't work somehow. Ah, it has to be mutable. Okay, and then we do next command equals next command chain mutable return this one, and we somehow got an error here. Mutable, what's the problem? Chain. Okay, there we go. Then pass the head commands. Okay, so next command, next chain, and we chain here the build load source files. Okay, I think this would work. Yeah, we just chain them like so. Yeah. I think that is simple enough, yeah. Load source files, build, disassemble. Okay, now the question is, how do we use this in here as well and analyze matched functions? Analyze name functions. Yeah. Okay, but this in itself, this should work to begin with, right? But now the question is here, analyze matched functions async. Update selected functions. Matched functions. Matched functions. Okay, so essentially in here, wait, we need to make a copy of this one. So in this function, we probably need to call name function indices 0 for comparison descriptor m files 0 maybe we should make a std array to call it name function indices array. Then we do for size t I equals 0, I smaller 2 plus plus I. Why do I always use size t in this case? Let's use integer. Let's use index t actually. Index t, okay, and then we use this stuff here. Span, basically name function indices array. I equals I, and somehow that doesn't work. Why not? Somehow doesn't work. Oh, it's a const span. There we go. I wonder if we should have a helper function maybe in the in files. Can we make a helper function for this? Hold on. Update selected functions, and when we create a span const index t, get items, get functions, get selected functions for processing. Hold on, this is wrong. Let's comment this out for now. We cannot use this here. Oh. We would have to use here selected matched function indices. Oof. Selected matched function indices. selected function indices. Functions that are visible and selected in the UI. How about we make two lists? We make selected matched functions and unmatched function indices. Maybe we should do that. For our purposes. Yeah. Well, selected. Or we do here, selected. Selected. Okay. Okay, how about we rename this to active named function indices? And this is selected named function indices. And then we need selected matched and unmatched. Maybe we rename this to all named function indices. Now the question is, do we need this now, all named function indices? Oof, matched. Maybe we don't use it then for now. We just use matched and unmatched. And so the matched ones we process. I just realized that if we had these things running in parallel, then this structure here runs the risk of crashing because it's not thread safe. Oof. Oh boy. Hold on. Does it? It's a map, so we do have stable references. File, text file, content. Text file, content. Yeah, if two things would load at the same time. I think this is not safe here. I think for reading, find content, it's also not safe. Well, this is safe, but this is not safe. So here we would need a lock. Yeah, this one. Oh, wait, this one is also not safe. Unless we remove this here, this assignment. Okay, how about we add a to-do here? To-do, make this stuff, make these functions thread safe. Yeah, it needs to be thread safe. Yeah. Yeah. Well, it should be possible. Okay, so all named function indices selected, matched, and unmatched. Okay, and so selected, update selected, matched functions. Oh. This. Selected matched functions. Yeah, all this needs changing then. Yeah. Okay, I would like to pick this up in the next session. I would just save what we have right now, which doesn't compile, but I think that's not a big deal. Yeah, let's continue in the next session with this. I will take a break now. Yeah. Okay, so next session we will implement these two, and then we try to use these for the commands here. Yeah, for this one here. Yeah. I think this gives us a bit more control. Yeah. Over the selection process. Yeah. Okay, yeah, let's do that. Good. Yeah, and then we need to make this guy here thread safe, wherever that class is, somewhere. Yeah, but it won't. Well, it will. Yeah. Yeah, it will be a problem even for now with UI, but it especially will be a problem if we have concurrent worker threads for our command queue. Yeah, like if there are multiple things trying to write to this file storage thingy, then yeah, there will be races and crashes. So this needs to be made. There need to be locks in this case. Yeah. We cannot make it lock free. But that's okay. That's okay. Yeah. That's fine. Good. Yeah, I will take a break here. Then, yeah, I wish you a great day or night until next time. Goodbye.